Okay, so now we're just going to look on the unit circle. And we have some angle x measured from the positive c-axis. Could be positive x or positive number x or negative number x. It could be any real number. But I just put it in quadrant 1 just to make the example easier to comprehend here, just to nail it down a little more. So if you make this little right triangle, going from where the terminal side intersects the unit circle, that point, the C comma S, from that point you can drop a perpendicular straight down to the C-axis and then a line from there to the origin, and you get this right triangle. And so the coordinate of that point there on the circle is C comma S, as it was before. And that on the unit circle will actually be cosine x sine x. So on the unit circle, the height of your point, if it's above the c-axis, is sine x. And the how far over to the right or left from S, well, let's just say to the right, we just do everything positive right now. How far over you are to the right from the S-axis is cosine x. So on your little triangle, the horizontal leg is cosine x and the vertical leg is sine x. Now, if you had a radius r circle, you'd have to scale everything up or down by r, so you would just take and multiply by r, so you'd get r cosine x comma r sine x for the coordinates of the point. That's how that works. Okay, so just to remind you, this is only on the unit circle that C equals cosine x and S equals sine x. I mentioned that on the previous video as well. So here's the definition. The book mentions this definition that I don't use all that much, but the problems that you'll be solving sometimes ask for this, so you need to know what this is. So the definition, given an angle x in standard position, its reference angle, rho, which kind of looks like a curvy P, but it's a Greek R. Rho is the smallest non-negative angle, non-negative, so it's 0 or positive, the smallest non-negative angle formed by the c-axis and the terminal side of the angle x. So for this one here, positive, it would be, rho would actually be x for this one. Now, you could have the same terminal side and wrap around the whole time. Remember, like 2 pi plus x, and you'd get the same cosine and sine, right? But rho would still be x, okay? So rho is always an acute, well, it's either an acute angle between 0 and pi over 2, or it's 0 or pi over 2, right? Remember, acute doesn't include 0 or pi over 2. So rho is greater than or equal to 0 and less than or equal to pi over 2. So for example, suppose I was in quadrant 2. My terminal side is in quadrant 2, and I have this angle x, right? Then rho would be the shortest distance, the shortest drop. You just drop a perpendicular, really, from the terminal side to the c-axis, and you measure that angle. So it's different than x if you're in the third quadrant. And rho is a positive number. So it's just like if you were going to draw a triangle here, which we do, as you can see here. The interior angles of a triangle, it's like we're just assuming those are always positive. So we're thinking of the triangle rather than the actual angle. That's the whole idea here. So if x is 3 pi over 4, which is what this illustration looks like, then rho is pi over 4.